Hey guys, thanks for joining me on episode 5 of the KZ440 EV Restomod. This installment is all about the traction pack housing. So specifically, I'll go through the design, the validation, and the first part of the build for the traction pack housing. So I'll have a little bit of CAD, a little bit of FEA, a little bit of validation and 3D printing, and we'll finish off with some CNC milled parts getting test fitted onto the bike. Now, one of the challenges is that I do actually need to have a fairly accurate CAD model of the frame because I do want to design this battery housing with a fair few CNC milled parts.
A long time ago in a workshop far, far away, I needed to come up with some way to digitize the frame without a 3D scanner. I used a foam core board to transpose the hard points back to a common plane, which could then be measured. I'm putting it all back in place for the video just to show how it was done. The top points were used to secure and hang the board in the frame. Then 3 large rectangular holes were cut where the mounts would be pinned. This was done so extra foam board could be floated on the pins that are put through the hard points, which is how the relative positions of these are located. Of course, this only works well with symmetric hard points, and partly why I tied the board to the frame at the top, because these are in the middle of the frame. The floating segments were then glued onto the main board once the positions were found. And since this whole process had been done a while back, the floating segments are already glued into place using hot glue. This can be seen on the back of the board. The 3 original rectangular sections that were previously cut from the board can now be put back into place. Then the holes can be transposed from the back. I found the old mechanical pencils worked well here again. The tip was able to make a small precise hole on the top side by pushing it through from the back. The main trick is to get the pencils into the middle of the holes made by the rods. Adding some thickness to the pencils by wrapping tape around the ends can help here. Once the holes have been pushed through, the positions can be measured off and triangulated between each of the points. The relative hardpoint locations were transferred to a CAD sketch, then used to model up one side of the frame. This lower half was then mirrored before adding the top mid tubes and the headstock. At this point I was fairly comfortable that the battery pack was dimensionally correct. I'd already validated this model with the physical pack a few months ago. I modeled a basic solid that would fit the frame and cover the whole pack. This was the starting point for the design. Once I was happy with the dimensions, I added some temporary tabs to the side of the box at the mounting locations and printed off some validation pieces just to confirm the alignment before going too much further.
So having a look at the mock-up relative to the hard points, it looks like I've actually gotten most of the mounts pretty well right. This bottom mount here is about 0.5 millimeter off, which is a very easy fix. In terms of the back side, the angles here as well as the radius on this part looks to be very close. I think I can actually use that. I won't need to really make any changes here for this. One of the main things I did notice though is that the angle of the frame compared to the model that I've made in CAD is a little bit off. So there's actually not much of a gap at the front here. And by not much, I mean nothing at all. So what I'll have to do is, in the model, angle this front section up a little bit and actually bring the bottom of this battery box up.
Once this was right, it was mirrored, shelled, and built into the final concept. It's going to be a largely fabricated aluminium box with CNC milled sides, CNC milled rear panel, and lower bracket. This FEA shows one of the 4 scenarios needed to satisfy the Aussie VSB 14 engineering requirements, showing that the box mounts can hold up during a crash. This analysis looked at a 20G frontal impact. Most scenarios showed that the highest stresses were at the rear panel mounts and the lower mounting bolt, but all are well within the material yields and the safety factors are all over 1.7 at the critical locations. It did take several tweaks and design iterations to get it to a point where the analysis was passable. I also checked the loading on the bolts to make sure they were up to the task. The heat map was set to 400 MPa to highlight really concerning areas, but all of the mounting bolts were well under this. I'll be using class 12.9 bolts, so the safety factor should be around 3 to 4 in most cases. And here's the final concept for the battery housing and the fin side panels for the electrical box that will sit above it. The fin box will have the motor controller and contactors shoehorned into it. think the finished concept really does hark back to the old school air-cooled cafe racer look. I did kind of go all out on this design, and the cost of machining the side covers, the rear panel, and the lull bracket are almost double the cost of the batteries. So I want to be absolutely sure that everything will fit first time around. Now, one thing to be aware of is the tolerance of 3D printers. My R19 that's printing all of the validation prints actually underprints by about 0.25%. So 3D printed parts are about 0.5 millimeter smaller for every 200 millimeters. I did have to make several small 0.5 to 1 millimeter adjustments on the rear panel mounts and the lull bracket after final validation prints were tested. The partial print of the rear panel mount fit perfectly at the printed size, which measured in at 0.5 millimeter smaller than the CAD model. So I just adjusted the model down to match the measured size. So happy with the partial, I then printed out the entire rear panel in 2 parts, as well as a lower bracket and a small segment of the top panel to bolt the whole lot up in place and test fit the entire assembly. This is the third variant of the lower mounted bracket, which had to be adjusted several times. This third attempt measured up as expected and fit perfectly. Another 3D printer quirk: holes are significantly underprinted, so they need to be drilled out for accuracy. Eventually, the whole rear assembly was bolted in place, but I also wanted to test the side cover as the main cost was in these pieces. I printed a 2D drawing and stuck it onto some cardboard so it would retain its shape. This could be hole punched and bolted into place on the rear panel to make sure the size and the gaps were right. I only gave myself one chance to get this right. So to make things interesting, the laser printer I used overprinted by about 0.5%. The printed part was ever so slightly touching the frame at the front, but taking that into account with the overprint, I told myself the actual milled size should be right. No pressure. One final check to see how far from the frame the side covers would end up to make sure they don't touch the front mount tubes. So now that everything was tested, it was time to bite the bullet and place the CNC order. Now I can spend 2 weeks crapping myself that I made a mistake on a measurement somewhere.
This is a genuine reaction. Wow. That turned out way better than I could have imagined. That is absolutely awesome.
As you can imagine, I was pretty nervous and excited to see how everything would fit. At this point, I'd already bolted the rear panel and the lower mount up to the frame, and decided to test fit the side panels just to put my mind at ease. Thankfully, the fit was perfect. Even the bottom gap was consistent and where it needed to be. I'd call this one a success.
How good does this look? I'm stoked with how this turned out. Still early days, a lot of fabrication still yet to be done. So in the next installment, we'll start to put together the main battery pack, the box, as well as the housing for the motor controller and the switch gear. And if you are enjoying the series, please don't forget to like and subscribe. That way you'll get notifications whenever we drop a new episode. Thanks guys.